Here are the Mod 14 Part 2 notes, confidence intervals for means. This is page 1. So, quick reminder, when we found our confidence intervals for proportions, we had a formula that looked like this. P hat was our point estimate, so that was our sample proportion. We had a z alpha over 2 score. That was the z score that cut off the bottom or the top little tail that we were working with. And then we had the square root of p hat times 1 minus p hat all over n, our standard deviation. Okay. Now we're going to find a confidence intervals for a mean. Notice the formula looks similar, right? So we have our point estimate. There is our x bar. That is going to be our sample mean. Notice here, instead of the z alpha over 2, we've got a t of alpha over 2. We're going to have to figure this a little differently. Notice up top here, we are not using sigma, the population standard deviation, like we have in the past. We're using S. This is our sample standard deviation. And then n, square root of n, here is our sample size. Now there are two main reasons we use the student t distribution, and we're going to pop down here for a minute. You'll notice it looks similar to the normal distribution. The tails are going to be a little thicker, but we use the student t distribution if, first off, we don't have the population standard deviation, which is most of the time, or our sample is too small. So our sample size is less than 30. Okay, so let's back on up here. There is one more new term that you need. So let's go through our ingredients up here and explain that. So x bar is our sample mean. About the same. A is the part in the two tails. Okay. So just like we figured with the proportion, that 90% confidence interval means that alpha equals 1 minus 90. So 0.5 in each tail. Okay, so we're going to calculate alpha and alpha over 2 the same way as we did when we were working with proportions. So if you see this, we're looking at the example with z-scores and t-scores. Notice they look exactly the same, except we don't just have the probability in our t distribution inverse function. We also have something called degrees of freedom. And the degree of freedom is going to take into account the size of the sample. So we've talked about t of alpha over 2. S is our sample standard deviation. N is our sample size. The new term here is our degree of freedom. That is 1 less than the sample size. That ensures that we are dividing by something a little smaller, which again makes our standard deviation just a little bit larger. Okay. So in Excel, I'm going backwards here. We've got this from above. X bar is our sample mean. I just wanted to give you the chance to write this out. S sub X bar is our sample standard deviation. We will need that so that we can find the confidence interval. N is our sample size. And our degree of freedom is n minus 1, less than the sample size. So the Excel command we're going to use to find a